So in this video, we're going to explore the idea behind a spectrophotometer and explain the key components behind the Raspberry Pi spectrophotometer that we're going to build. Hi, this is Grace.
Hi, this is Neil.
And together, we're Atomic Kitchen.
I think you should start by explaining what a spectrophotometer is.
Okay, it's a device for measuring the colour of light. Light's made up of different waves. We can describe waves by their amplitude, that's how big they are, and their wavelength, that's the distance between one wave and the next wave starting. Different colours of light have different wavelengths. So what we'll do is we'll make a device that measures the wavelength of light. The wavelength of light is very, very small. It's measured in nanometers, and visible light's in hundreds of nanometers. A nanometer is 1/1000th of a meter, so it's absolutely tiny. We can't measure it with just a ruler. That device that we're going to build is a spectrophotometer. The light we see all around us is actually made up of lots of different wavelengths. So when we see white light, it's actually made up of all the different colours merged together. This is a diffraction grating. We'll talk more about them when we get to that bit of the video. But if you take that and look through it up at the light up above, what do you see?
A rainbow.
Excellent, exactly. So you see the white light spread out into all the different colours of the spectrum.
It's pretty.
This diffraction grating is actually a thin piece of plastic with 500 lines on it every millimetre. They come in different sizes. We've got an example here that's 500 lines, and we use an example that's 1,000 lines when we make the spectrometer as well. So what we've done now is we've put the webcam inside a little box just to control the amount of light that gets to it, and then we've put the diffraction grating in the box there, and they're just sitting at a nice angle so that we can see the light that comes through a little hole in the front of the box, fracted out, separated out by the diffraction grating into all its colours, and then hits the webcam that we've been using to film this. So now you're seeing something similar to what Grace was seeing when she looked at the light. If we just put the diffraction grating directly in front of the webcam without the box around it, too much light gets through and all you see really is white. But you can see it split out all the way through from red, orange, yellow, green, it goes kind of turquoisey, blue, and then a darker blue or sort of indigo colour. So we're seeing all of the colours of the rainbow there. And that's exactly what happens when we have a rainbow as well. A water droplet is splitting out the colours of light. So that's the first job, is to take the light that comes into the spectrometer and split it out into all the different colours. Then we need to measure how much of that light gets to it. And for that, we're going to use this tiny little camera here. So if we unbox it, it's a tiny, tiny little board. And on the end here, we have a camera. It's still got a little protective cover on it at the moment. But we're going to spread the light out into the spectrum, just like Grace described, so into the rainbow that Grace described. Yeah, and we're going to put that rainbow onto this camera chip. And to understand how that's going to work, we'll need to explain a bit about how cameras work, or digital cameras work. Yeah, and so we'll make a whole video all about that in itself. But then we're going to measure that by plugging this little camera into this Raspberry Pi Zero board.
The Raspberry Pi is very small.
It is. So this is a Raspberry Pi, and all Raspberry Pis are single board computers. But this is a Raspberry Pi Zero, which is the smallest, cheapest one they make. It's not quite the very cheapest one because I've been lazy and gone for the Pi Zero W, so it's got wireless on there as well. But this is less than $10 to buy.
How much pounds?
I think it was £9 to buy this. Yeah, so it's about a $10 computer. Essentially, it has a very clever processing chip on here. We will put into it in here a little SD card like you might have on a phone, a little memory card that will contain the operating system, and we'll use the Raspbian operating system, but that's a form of Linux. So it's the same sort of operating systems found on all sorts of computers all over the world. And we will plug in a power supply. We might plug in a keyboard so we can actually program it. And we will plug in a little display so that we can see what's going on as well, maybe. So we might plug in a little HDMI adapter so we can put it onto a television screen. Or we can connect that directly to our computer as well, but that's why I went for the Wi-Fi version. So we can control it all from the computer and see what's happening.
Cool.
So that's covered most of the components. What have I not talked about?
And the razor blades?
That's right. So we've got a pair of razor blades here. And what they are is just two very, very, very sharp edges. And we're going to hold them like this. And they're very, very close together. And that will give us one vertical line. And that means that when we look at something, we get an effect a bit like a pinhole camera. We can talk about that a bit more when we get to this bit of the construction. But essentially we're going to get a very sharp image onto the camera. So we're looking at one thing at a time, not lots of different images of the same thing.
Got it.
Okay, so that's probably the key components to think about. We're going to take white light. We're going to pass the white light between the two razor blades. And then we're going to pass it through the diffraction grating to spread it out into all the colours. We're going to put all the colours onto the camera chip, and then we're going to use the Raspberry Pi to measure how much light arrives at each pixel of the camera chip. And we'll get out from that a graph, and as we work through this, we'll turn that graph into a graph of wavelength against intensity, so against how much light's there of that wavelength.
Cool. So why don't we just use the webcam instead of using the Raspberry Pi one?
That's a good question. And there are lots of people around on the internet and YouTube who have used a webcam and some software you can download for free, and then maybe instead of using a diffraction grating have used a CD, because as you can see, depending on how you hold that, you can just see a kind of rainbow pattern or a diffraction pattern coming out of the CD as well. So you can do all those things, and I think it might be interesting to go and measure later and see how does a CD compare to a diffraction grating. It might be an interesting experiment to do. But the reason I think we should use the Raspberry Pi camera is the specification for it and the way you can control it means we can do some much more precise things and actually understand how we're doing things.
So you've talked a lot about diffraction gratings, but you haven't really explained what they are.
Oh, okay. Well, I think that would make a whole video in itself. So let's make another video which will talk through what diffraction is, and then we'll talk through what a diffraction grating is and how we're going to use it in this application in a lot more detail and explain some of the science, the physics behind diffraction and diffraction gratings.
Okay. So you can see when that video comes out. Don't forget to subscribe so you can hit that notification bell, and I'll see you all next time. Bye!